I'm sharing my screen. So in the last class, what we have seen, just why do we need a UVM when we already have the system verilog? Okay, system verilog it's a hardware descriptive language and verification language, and it is a robust and this uh, so and so UVM is not a language; it's a methodology. Okay, we are using whatever the system related concepts are there on the UVM we studied. Okay, we seen, and UVM is a framework on top of the system that standardizes the verification environment. And so basics of the SV we seen like in early days in 1990s we used Verilog. Okay, initially Verilog test benches. So Verilog test benches. So we need to write the directed test cases manually. So hard to scale for complex designers and low reusability is there. Okay, so separate modules we need to write the separate test benches we already seen. And system Verilog. So we use some more concepts like OOPS, polymorphism, randomization, and so making the test bench more structural, okay, structured. So it is standardized around 2005. And what are the improvements over the Verilog means we are using constrained randomization stimulus and functional coverage and assertions, all those things we have seen. And limitations mean there is no standard structure for the test bench to be seen. Like this is robust. That means there are no guidelines for the stimulus generation. So so we need to come from the scratch. Suppose if you writing the test bench for I2C separately, you need to develop the test bench for SPA. So you need to come from the scratch. Okay, there are no guidelines for this. So UVM they given standardized around 2010. Okay, so this is a methodology, and that is developed by a company called Accelera. Okay, majority of vendors, whatever the whoever the EDA vendors are there, they will compatible with UVM only. Okay, suppose if UVM is not there, different companies will come in different industries will use for the test bench for their own methodology. Okay, so that's why so due to this, all companies, all industries will follow this UVM only. Okay, and key features are modularity and reusability. As I told you, so most of the say if you want to verify the I2C, next if you want to verify the SPA, some with small replacing some small protocol specific sequences, you can reuse the same test bench so that so you can so what you can do, you can improve the means you can save your time. Okay, save your time and design to market and all those things. And basically in the SP we already seen in order to communicate between the generator and the driver or monitor, we are using like mailbox. Okay, there is one disadvantage also we already seen. We need to create each and every handle for communicating with component A and component B. So here we are making TLM ports. Okay, TLM means a transaction level modeling ports. Okay, TLM based communication, and that we'll discuss in the coming classes. Okay, so TLM based communication is used in the UVM. Okay, so this is a structured test bench we already seen component. So that is divided into two parts. That is the component branch and sequence branch. So component branch is having the hierarchy. Okay, so UVM underscore object is the base class. Okay, this is my base class, and under this the UVM underscore report underscore object has the child class. Under this UVM underscore component has a child class. There is a hierarchy, but here there is no involvement in the hierarchy sequence branch. It's we have transaction class and transaction and mailbox are there in SP. No, like that. This will not take part in the hierarchy. UVM underscore transaction, UVM underscore sequence underscore item, and UVM underscore sequence. Okay, so so UVM components will represent the UVM components. We'll use via a constructor called create that we'll discuss. Okay, so those are connected with the TLM ports. Okay, And UVM objects, okay, it's a data containers or non-hierarchical utility objects. These will not participate in simulation phases. And this is my test bench, SV test bench. Actually, it consists of test environment, scoreboard, okay, and after that you have monitor, generator, monitor, driver, and that is given through the interface to the DUT. This is our test bench we discussed in SV. Okay, actually, like in UVM, you have test environment and you have a agent. Okay, agent, you have monitor, driver. In place of generator, you have a sequencer. This is connected to the DUT. Okay, so this is the basic test bench for the UVM. Okay, so test environment, and in the agent you have sequencer, monitor, and driver, and scoreboard and reference model also there. So we already seen like UVM objects, there is a hierarchy I told you, know, UVM report objects, UVM components. In this UVM components, you have UVM test, UVM environment, UVM scoreboard, UVM agent, UVM monitor, UVM driver with argument request and respond, and UVM sequencer, sequencer base, and UVM sequencer. So in this component class, you have UVM transaction, UVM sequence item, and UVM sequence. Okay. So this is basic test bench for UVM. Okay. So test on the top module, there is like interface and DUT. So under the test, there is an environment. In the environment, there is a scoreboard. So scoreboard will give the coverage, how much of coverage it will give, and in place of generator you have sequencer, monitor, and driver. Okay, so through the sequencer sequencer, so through the TLM ports it is given to the driver. So driver give the stimulus to the DUT, and DUT, from the DUT it will process, and it is given to the monitor. So monitor will monitor whatever the output for the DUT, and it is given for analysis report. It is given to the scoreboard. Okay. So this is the basic test bench for the UVM. So class driver extends UVM underscore. How to, like we need to extend, how we are extending, like we need to use class. If you are extending the driver class, all are there in a UVM, that library. Okay, we need to do the registration, that we already seen. Okay, UVM underscore driver, UVM monitor extends UVM underscore monitor, like that you can extend. So in SV you have test environment, generator, driver, monitor, sequence was sequence board, and reference model. And here you have test environment. You have different agents. Okay, suppose different for SOC if you want. So in the agent you have driver, monitor, and sequencer. Okay, and here agent 2 you have driver, monitor, and sequencer. Suppose if you want to write for I2C, so I2C it will create one agent. UART it will create one agent. Okay, like that. Okay, different models. Okay, SPI it will create one agent, like that. And we discussed about passive and active agents also. Passive means what? Driver can be, or sequencer can be inactive, or monitor can be active. That is passive agent. Active agent means all will be inactive. Okay. So driver, sequencer, monitor could be active. Okay. So that we have already seen what is UVM agent. Okay. So UVM agent is nothing but like container. Okay, all the components are interact with this interface through the DUT of the DUT. So mainly we can connect AXI, SPI, UART, all those to the agent. Okay, and this also we already seen, UVM agent, passive agent, active agent, and UVM factory. Okay, UVM factory. So this is the fundamental part of UVM, Universal Verification Methodology, that enables the dynamic creation of objects. Dynamically, we need to create the object. Okay, so like components in a UVM test bench. Okay, so the standardized way. So what happens? This allows the flexibility, reusability, and configurability. Okay, we can reuse the test benches whatever we already wrote. Okay, so UVM factory. So UVM factory mechanism is UVM that responsible for creating UVM objects. Okay. Normally, like in SV, traditionally what we did, we used a new method for creating the object. Used new method, but in factory that uses factory registration. Okay, so like if you buy a car or if you buy a bike or land, you need to register to your bank, no? So like that it should make a factory registration. Okay, so what are the key features of this UVM factory means object oriented programming. Oops principles such as polymorphism will be there. Okay, factory overriding, that we'll discuss. What is this factory overriding? Okay, so factory overriding means we can replace class instance with subclass instance dynamically. Okay, and it will help for reusable and configurable. And next, so overriding means what? We are replacing. We'll see with one example also. We are replacing one component with another component. That is overriding. Okay, and here suppose if you want to do the factory registration, here I need to do like this. Okay, so how to do, like first class. So this is the like this you need to do class component extends UVM underscore component type def. Okay, type def UVM underscore component underscore registry underscore my component type ID. Okay, so what is type def? We already seen in system Verilog. Can you say anyone what is type def? What is type def? We can create our own data type. So that means here actually, like we call type def is, let us suppose if you consider int a. Okay, so here a is what, this is data type. Okay, this is a which type, int. Wherever you use a, that is becomes the data type. Here this is what, this is my class. This is my class. Okay, wherever you are using this is my class. I told you in system verilog, this is also my data type. Okay, this is also my class, is also one my data type. So wherever you are using static function type id, get it underscore type id, return type id, scope resolution operator get. Okay, this is my method end function. Okay, so by using these codes we can do the factory registration. Okay, so in order to do this, we can do like factory registration using macros. We already see. Suppose if you want to do for component, okay. So how to write? So that is class my component extends UVM underscore component tick underscore component utils my underscore component. This is registration. Okay, so by using macros are nothing but like already predefined codes are there, you are calling that macros. Okay, parameterized components means like this you need to define class my param component int add width equal to 20 int address width equal to 20 data width equal to 23 extends UVM underscore component. Okay, so type def my param component, and after that tick UVM param utils this underscore tick. Okay, so that means this total type def means what, this total param, this one is there, no? I am initialized to this underscore t. So here I can use this underscore t. Okay, for derived classes from an object, how to write? So UVM underscore transaction, UVM sequence underscore item, UVM underscore sequence etc. Class my underscore item extends UVM sequence underscore item tick object tick underscore object underscore utils my item. Okay, my item. So this is for class derived from the object. Like this you need to write. Parameterized objects means you need to write like this. Okay, class my item int address width equal to 20 int data width equal to 20 extends UVM underscore sequence underscore item type def my item with this underscore t UVM underscore object underscore param utils this underscore t. Okay, like this we need to write. Okay, I think till we already seen, no? Is it fine? Hello. Till here we seen in the last class, no? Yeah. So that means if you see like yeah. So here I'm writing. So So in order to registration, okay, registration, what you are doing for doing registration, what you are doing, that is, so you are doing type type def UVM underscore component underscore registry and class name, okay, class name and type ID, okay, type ID. This total class, whatever this total class is there, I am declared with this one type ID, okay, wherever I am using this type ID, so this will be related to this one, okay. So next what I am doing, function type ID, type underscore ID, get, I am using this function get, okay, and return type ID, type underscore ID, okay, scope resolution operator, get, okay, get, okay. So this total thing is what, factory registration, okay. So this is the code for what, this is the code for factory registration code, factory registration code, okay. So instead of writing above code, okay, what you need to do, so we'll write tick UVM underscore component underscore utils, okay. This is for what, component, okay, this is for component, okay. Suppose UVM tick UVM underscore object underscore utils, okay. This is for what, I'm writing for the object, okay. So so here whenever you are registering your class, so you need to write, suppose here for driver I'm writing, so how to write, first you need to write class driver extends, okay, UVM underscore driver and next here we need to write tick UVM underscore component underscore utils and here you need to write drivers, okay, driver, okay, like this you need to write. So for registration purpose, so that means what you are doing, basically you are telling UVM library that you have some classes which are known your driver, okay. So basically like you are creating, so you are going to get your ID, that ID is there in which one, UVM factory, okay. So from the UVM factory, okay, UVM factory, you are getting you are registering your ID, okay. So all these are there in the UVM factory, okay. So from the UVM factory you are getting this ID through this one, okay. Is it fine? So this is going to provide an ID, so by using this we can going to provide an ID. Is it fine? Shall I move forward? Okay. uh, so suppose in SV, suppose in order to create suppose if you want to create an object, how you created, tell me, anyone, how you created an object, how you created an object? Yeah, first you need to create the handle, and into for creating the object you need to use a keyword called new, no, new. So keyword called new, but so use a keyword called new. uh, so here we need to create, so here in UVM, we are using one more keyword, that is create, okay. This is one more keyword we are going to use, okay. This keyword we are using to going to use to create an object, okay. So using create we are going to create instance for an object using create, okay, create keyword, create. So create only, we are going to we are going to create the instance, whatever the instance is there, instance for our object, okay. So here in the SV we used this one, and and uh, and next here we are using this one, okay, this create, okay, create we are using. And next is constructor defaults in UVM. So UVM, the UVM underscore component and UVM underscore objects, okay, constructor are virtual methods with prototype templates that must be authored by the user, okay. Both UVM component and UVM object classes have virtual constructors. In the sense, their classes, subclasses must be specified constructor signature, okay. So like basically, like if you see, uh, so what is so example, example here you see, uh, so you have example, if you take, you have UVM object, okay, UVM object. After this, UVM underscore report underscore object, and next you have UVM underscore component UVM underscore component, and next you have UVM underscore driver, UVM underscore driver, okay. These all are we call as a virtual classes, okay. All classes, all are virtual classes, okay, virtual classes, okay, virtual classes, okay. So actually, like we call as, like in SV, we have a pure virtual class. What can anyone say, what is pure virtual class? Pure virtual class we already seen in SV. Pure virtual class, we already came across this pure virtual class. Can anyone say what is pure virtual class? This is one prototype. This is one prototype without any body, without any body. This is pure virtual class, okay, without any body. Virtual class means what? Virtual class means, so here you have virtual class. We can extend, but we cannot create the object. We can extend, okay. We can extend, but we cannot create object, okay. So we cannot create the object, okay. So we can say that in UVM. So in UVM, I can write it in UVM. All the built-in classes, whatever the built-in classes are there. So all built-in uh, classes, classes we have, which we have in library are virtual classes. Okay. So which we have, in library, in standard library are virtual classes. Virtual classes. So virtual classes means what? So that means here virtual classes are like, we can extend that class, but we cannot create the object. Okay, so we cannot create the class. So that means, so here there is already a pure virtual function declared as new keyword. So virtual class means what? We cannot create instance for UVM. Okay, so that means we cannot. So virtual class means we cannot. So we cannot create. So we cannot create an instance for UVM, for UVM. Okay, for UVM we cannot create. Okay, suppose UVM underscore driver is there. Okay, so uh, that means here, UVM underscore, if you take UVM underscore driver is there. Okay, UVM underscore driver is there. So this is one virtual class. This is one virtual class, okay, which is going to have a pure virtual function, okay, which is going to have a pure virtual function that is new, okay. So like how to write uh, so here function new. How to write this new function new and some piece of code end function, okay. So which is not having any body in this, okay. So this is a class which is not having any body in this, okay, any body in this, okay. So this is a virtual class. All the classes present in the UVM are virtual class, okay. So that means when you extend virtual class, do you need to override pure virtual class? For sure, we cannot leave it, okay. So actually we need to override pure virtual class must be overridden, okay. So we need to overridden or else we are going to get an error. Suppose if we are extending your virtual class, okay. So we need to override this pure virtual class, okay. Otherwise you are getting error, okay. So how we would, so by using overriding, we need to do the add page, okay. So pure virtual class, whatever the pure virtual class is there, you need to you must be overriding, okay. Pure virtual class, which pure virtual class must be overridden. Okay, pure virtual class must be overridden. Okay, or else you will get an error. Okay, or else you will get an error. You will get an error. Okay, so how to write? So that means how to write for this virtual class? Class, I am writing here. Class driver, extends UVM underscore driver, okay. Class extends UVM underscore driver, okay. UVM underscore driver, okay. So what is the syntax? So syntax is uh, function function new followed by name, so name comma parent, these are the arguments, okay. So these are the arguments you need to pass, okay. And next you need to use a keyword called super dot new name comma parent and end function. So you need to override this so you need to override this pure virtual class, okay. Then only that code will pass. Otherwise, you will get error, okay. So in SV project we already seen, okay. So how many arguments you are passing? So you are passing two or more arguments, no? So in SV, when you developed the project for dual core RAM, okay, dual core RAM. So you're writing for code for driver. Just to check that. So you passed more than two arguments, okay, more than two arguments, okay. But in the UVM, you need to pass only two arguments. Okay, two arguments you need to pass. What are those arguments? Those are name comma parent. Okay, is it fine? How we are overriding your pure virtual class? So this is the syntax for overriding your pure virtual class. Is it fine? Shall I move forward? Yeah. Suppose like you are developing your core, you are developing your driver. Okay, how you are developing your driver? So this is the basic part when you are writing the code. Okay. So this will be compulsory present in your code. Okay, that I will show you. Don't worry. So here developing, suppose if you develop your driver, developing your driver. Okay, how to write for this driver? Class driver, class driver extends UVM underscore driver, UVM underscore driver, and function you need to use new function new driver. This is a string, okay, string type. That's why it's a double quote and comma this. Okay, so that means here, so this driver is a what? This driver is a parent class. Okay, driver is a parent class. Okay, so actually like you have, so you have like test. So you have test, and next you have environment. Okay, in this there is a driver. Okay, there is a driver. Okay, so this is my base class. This is my base class or parent class. Okay, suppose another child class is there, means there is one more driver class is there, that is child class. Okay, so using this driver you are extends one more child class. By using this keyword you can drive another driver class as a child class. Okay, so this means what, using this keyword you can use, this is a base class. This is my base class. Okay, and next you need to use super keyword, super dot new, super dot new, and here you need to use name comma parent, name comma parent, and end function. Okay, so it will look like a new only, just to try to understand. Okay, so suppose how to write means function new uh, string name, string name that is equal to driver, string name equal to driver, and next and this is not there, function, no, yeah, function, next UVM underscore component. Okay, comma, so how to write means here comma UVM underscore component equal to null, and next super dot new bracket name comma parent, name comma parent. Okay, like this you need to write. Okay, so if you see the, so this is developing your project. Okay, your driver. Okay, developing your driver. Okay, suppose like uh, one second. Yeah, so if you write a UVM code, so how to write means here where I am writing UVM code, UVM code. So for component, how to write means so class my underscore component. Okay, for component I am writing. Okay, component, and next extends UVM underscore component, UVM underscore component, and function new string name. I'm using I'm giving string name. Okay, string name is what, string name equal to my component, my underscore component, and next comma UVM underscore component, UVM underscore component, that is equal to null, that is equal to null, and next I need to write super dot new and name comma parent, name comma parent and end function. This is the component. For the component I need to write the function. Okay, for like this I need to write the function. Okay, and coming to the object. Okay, so for object creation, how to write for an object, class my underscore item. Okay, extends UVM underscore sequence underscore item. Okay, item, and I'm using function, my function name, that is I'm using a keyword called new. Okay, string name, string name that is equal to, I need to use my underscore item. Okay, item, and super dot new, that is name and end function. Okay, so here so this string name, whatever the string name is there, that is not involved in the test bench hierarchy. Okay, so that is only first argument, that is string name equal to my item. Okay, so whatever this is there, this is not involved in the test bench hierarchy. Okay, not involved, whatever this one is there, not involved in the test bench hierarchy. Okay, so which one is involved? Component is involved in the test bench hierarchy. Okay, so test bench hierarchy. Okay, so this is a component. So here what you are doing, you are not we are not using we're not using new method, then we are going to use create method. Okay, so here we are not using new method. So what is create method? Okay, so in this we are not using the new method, then we are going to use, so suppose if we are not using new method, then we are going to use create method. Okay, what is this create method, we will see. Okay, so create method, if you see the create method, this is create method. Okay, so create method in UVM, create, so this is a keyword. Create method is a factory method used to construct an object or a component dynamically. Okay, it is used to construct an object or component dynamically. Okay, dynamically during the simulation. Okay, without directly calling the constructor new yourself. It's a part of factory design pattern. Okay, it's a part of factory design pattern in UVM, which allows flexible and overridable construction of object and component. Okay, by using keyword, we can construct an object or component dynamically. Okay, how to create, we'll see. Okay, so how to create, we'll see. Okay, so here, so we need to use a keyword called create in the UVM. Okay, where in SB we use the create new method. Okay, so how to create your this creating your creating the object for UVM component, creating the object for UVM component. So how to create an object for UVM component means, suppose I am writing my underscore driver, and what is my handle name is DRV. Okay, this is my handle name. Okay, this is my handle name. So this is my handle name. Okay, so first you need to declare the handle. Declare the handle. Okay, after that, uh, so you are calling, that means drv, that is equal to uh, my underscore driver, Okay, so what is this? This is the class name. This is the class name. Okay, and next you need to use scope resolution operator. Okay, this is scope resolution operator. Scope resolution operator. Okay, and after that, this is the scope resolution operator. and after this mm, type id, type underscore id. Okay, type underscore id means you created the factory registration, no? So factory registration you wrote one code. Okay, so what is that code we written? So first of all I showed that code. Okay, so that is type def UVM underscore component underscore registered class name type id. Okay, so this whatever the type id is there, so function type id get. Okay, this type id I'm calling. Okay, type id in here I'm calling this type id. Okay, type id. Okay, and again scope resolution operator, scope resolution operator, I need to use a keyword called create. Okay, create. Okay, and I need to pass the handle. What is my handle? Drive. What is my handle? Drv, drv comma this. Okay, so drv comma this means what here? This is actually this is I need to pass the handle. I need to I need to pass the handle. Okay, pass the handle. Okay, and this refers to what? This refers to the parent class. This refers to the parent class. So whatever the handle is there, I am passing to this drv. I am passing to what? This drv. Like this I need to do it. Okay, so again create, you have two methods, two arguments. Okay, so what are these? That means create you have two arguments. What are these arguments? Drv and this. Okay, so for this create, what I am writing, create create string name that is equal to, you need to use one string UVM underscore component underscore parent. Okay, so in SV what you done? Can anyone say in SV how you done? First you created my handle, no? What is my handle? My underscore driver, that is what is my handle name? Drv. Drv equal to what? New UD. With new keyword you created an object. But in UVM you need to write like this. Okay, drv equal to my underscore driver, and you are registering. How you are registering in the UVM factory? By calling this type id. Okay, type id create. You need to use a keyword called create, and you need to pass that handle. Okay, so that is drv comma this. This refers to the parent class. Okay, is it fine? What is? Did you understood? Did you understood this? Hello. So what is happening over here? What is happening? So what is happening means, so you wrote a separate code for UVM registry, no? Class driver extends UVM underscore driver. Okay, UVM underscore driver, and used type def UVM underscore registry. Okay, hash driver. Okay, this is my argument, hash driver type id. Okay, type underscore id. Okay, and function type id, type underscore id, and I'm using get, and next return type id, type underscore id, scope resolution operator, get an end function. This total function I'm calling here, calling in this. Okay, the total function is the total code what I wrote, I'm calling here. Okay, instead of writing all these codes, what I need to write? I can use macros, that is tick UVM underscore component component underscore utils and driver. I can write with one line of code. I can call all those things. Is it fine? Do you understood? So whenever you are registering a class, a ID will be created at each and every class. That is ID is present in this one. The ID is present in this one. Okay. So like this. So suppose if you want to create, create this. So how to write? So that means drv equal to my underscore driver, and scope resolution operator type id, type underscore id, and next you need to use a keyword called create, and I need to pass the handle, that is drv comma this, comma this. Okay. So this is what, so you are creating the object. Okay, you are creating the object. Okay, this is, so that means, so UVM registry will create the object for the handle drv. Okay, what this UVM registry will do? UVM underscore registry is there, no? So UVM underscore registry will create the object, whatever the object is there, object for the handle, drv. Okay, handle drv, it will create the object. Okay, so it will create the object, that is drv. Okay, so whatever the UVM registry is there, that will create the object, and this is my class, my underscore driver is my class, and you are calling the function called type id. Okay, type underscore id means what? You are calling, function, whatever the function called type id, type underscore id. Okay, it's present in where? It is present in UVM registry class, UVM registry class, registry class. Okay, and this is a method or a function. Okay, this is a method or function. This is also present in UVM registry, and you are passing your handle, whatever the drv is there, you are passing your handle, and this is related to this parent class. Okay, this keyword is nothing but like driver is a parent class. Is it fine? Do you understood? Suppose example, if you take, suppose here you have UVM component registry. Okay, so here you have UVM component registry. Okay, registry. Okay, and you have a keyword create also. Okay, create also. Okay, so this will create the object, Okay, so how to, for creating this, you need to use what? Here you need to use driver drv. Okay, driver drv, and drv equal to, this is my handle. Okay, drv equal to what? My underscore driver scope resolution operator, and UVM underscore registry driver and again scope resolution operator create. Okay, so that means here what happening? You are creating a handle that is to the driver. Okay, that is to the driver. You are creating a handle in this, that is, what is my handle name? You are copying into the driver. Okay, like this. Okay, is it fine? Do you understood? Any doubts or queries? Create is a function. Okay, create is, it's a method or a function we are going to use in the UVM. In SystemVerilog you used SV, no? So so what it will do? It will create an object and it will return to it. Okay, so create is an object, is a function. It will create an object and it will return to it. Okay, so this is how I am creating my handle. Did you understood? Any doubts or queries? In SV, we started with classes. Okay, when you are writing the classes, the object will be not created. So there, what I discussed, that means you need to create the handle, and then after that, by using a new keyword, you need to create the object. Then only my memory will be created. My means my object will be created or instance will be created that I told. So here there is another way of creating the object means this way. This means drv equal to my underscore driver scope resolution operator UVM underscore registry and driver and create, like this you need to use. Is it fine? Shall I move forward? Any doubts or queries? Shall I move forward? So next we'll start with one example. Okay. Suppose, yeah, I'm starting the EDA playground. So register with your mail ID. Okay. Register with your mail ID. And next here, so for writing the code, you need to select SystemVerilog or Verilog. In the UVM, you need to select UVM 1.2. Okay, you need to select this UVM 1.2 and tools and simulators Aldeck Rivera only. Okay, so you are developing the test bench. I am writing the test bench for this. Okay, so you need to use two header files for this. You need to include the header files in the library. For every code, you need to write. Okay, so what are the header files? We will see. Include, tick include. Okay, double quotes, UVM underscore macros, UVM underscore macros dot svh. Okay, svh. This header file you need to include, and next import UVM underscore package, UVM underscore package, and scope resolution operator and star. For every code, these two header files are there. Okay, remember for every code, two header files are there. And next, what I am doing, I am writing the code for the driver. Okay, how to write the code for the driver? Class driver, class driver. I need to use a keyword called extends. Okay, extends UVM underscore driver. UVM underscore driver. Okay. Next, I'm declaring one variable that is int a. Okay. I'm declaring one variable int a. Okay. Int a. So I'm using macros only. Okay. I need to register these driver components into the UVM factory. No. So in order to use that whole code, I'm using the macros only. How to use the macros? That is factory registration. UVM underscore components okay underscore utils underscore utils. Okay, so what is my component name? Driver. Okay, component name is driver. Okay, driver. So this is what UVM factory registration. Okay, UVM factory registration, factory registration. Okay, and next what I need to do, I need to write function. I need to create this one. No, okay, function new. Okay, string name. Okay, equal to string name that is equal to uh, so driver, string name is driver comma UVM underscore component component underscore parent that is equal to null. I am giving. Okay, null. Okay, null. And next super dot new name comma parent, Okay, and end function. end function. Okay, end function and end class. Okay, this is common for all the codes. You need to create the handle for the my driver class. Okay, so this is how you are creating the handle for the driver class, and after that I am writing module tb module tb initial begin begin. I am creating the handle driver. Okay, drv. Okay, and next so how to create the object drv, that is equal to driver. Okay, scope resolution operator, and next type underscore id again scope resolution operator, create create okay, create, and next drv comma, where I will give null. Okay, null, and next drv dot a, that is equal to I am giving some value 10, and next I want to display dollar display drv dot a is percentage d comma dot a end and end module. Is this code fine? Did you understood? Is this code fine? Just to give response so that I will move forward. Okay, so here next what I need to do, uh, so run simulation. One second, I am getting error. Unexpected. This codes I wrote. This is the code only I wrote. So tick include UVM macros driver extends UVM underscore driver. This one I need to write. Driver extends UVM sequence items. Okay, this one just select all, copy, and here I'm pasting over here. So just run this code. So see here, what is my output? drv.a is what? 10. Is it fine? We got the output or not? We got output or not? Shall I move forward? Do you understood? Yeah. Next is I will tell you one example with component overriding. So component overriding. This is component overriding. So there is like two components are there. So here this code is related to what means here you have two components. Okay, component A and component B. Okay. So in this, what I am doing means there are two components are there. Okay. So like in this code, there is one component is there. Component A. This is component A. Let us take this is parent class, and next there is a component B. There is a component B. This is let us take child class. Okay. This is the code related to overriding. Okay, overriding concept. Next there is my test, there is my test, one test is there, test, inside test there is component A is there, okay, one component A is there, okay. So I need to override component A into component. So I need to, so here I, what I need to do, I need to override, okay, override, I need to override component A into component B, into component B, okay, component A into component B. This code I need to write, okay. So just we'll see how to write this code. Did you understood my how I, what is my thing? Did you understood? Shall I move forward? Yeah. So just you see, one second, one second. Yeah. So here you see. First, I need to declare with tick include UVM underscore macros and macros dot svh import UVM underscore package. First, I am declaring the component, that is class component underscore a extends UVM underscore component. Okay. So next, I need to do the factory registration. No, tick UVM underscore component utils component underscore a. Okay. Next, I need to create this one, create an object, that is function. I need to create with a new function. So function new, string name is component, UVM underscore component underscore parent equal to none. Okay, UVM component parent equal to none. Super dot new is name comma parent. So I am passing two arguments. Those are name and parent. End function. Okay, and next I am using one virtual function void display. So tick info get type name inside component a UVM comma low. This we will see. Okay, don't worry for this. Okay, this we will see in the coming classes. And next I am declaring component a component class component underscore b extends component a UVM underscore component underscore utils component b, and I am creating the function function new, string name is component b, UVM underscore component parent equal to none, super dot new name comma parent end function. Okay, and similarly function void display function also I am writing. Okay, so don't worry about this display function. So here class my test extends UVM underscore test. Uh, Here there is like build phase is there. Okay, build phase, run phase. We will discuss in the coming classes. Okay, don't worry about this. Just you see this one. So there is I am doing overriding. Okay, set type overriding all component A creations becomes component B. See here component underscore A. How we are doing the overriding? Scope resolution operator type underscore id, again scope resolution operator set underscore type underscore override component b scope resolution operator get underscore type. Okay, so here with this command what happens, we can replace one component with the other component. Okay, we can replace one component. I can override component A with component B. Okay, so remaining that run phase, build phase, all those things we'll see in the coming classes. Just my code is what I'm overriding component A with component B. Okay, so this one I'm executing. Just select all, copy, and see in the EDA playground. Just paste here. First, I will comment this. Okay, I am not overriding. Okay, I will comment this. Okay, so I will see. Okay, I will run this code. I'll run this code. What is the output I am getting? I want to check. See here. So here you see. So UVM information. UVM test component A inside component B. Okay, component A inside component B. So that means there is no overriding happening. Okay, component A inside component B is coming. Okay, and after this I will uncheck this. Okay, I will uncheck this and I will run this. What I am getting? See here. So here you see. So overriding is happening. See here, UVM test top component A, component B inside component B. So that means overriding is happening. Okay. So like this we can do the overriding. Did you understood how I am doing the overriding from component A into component B? Okay. So okay, one more copy code is there that we'll see in the Monday. So till now you analyze this concept. With that we will complete the factory registration concept, and next we'll go with the next topic. Okay, is it fine? Shall we wind up?